Okay, in this example, I'm going to investigate a system of three planes defined by these equations here. And I'm going to start to look for any intersection points. I believe they might intersect at a single point. I might not be sure, but I'm going to set out to see if I can find out what's happening. So to start with, I'm going to pick one of the variables to eliminate from two pairs of the equation. It doesn't matter which one you choose. In this example, just for this example, I'm going to eliminate the variable x. And first of all, I'm going to do that from one pair of equations, and then I'm going to eliminate it from another pair of equations. So I'm just going to be systematic. I'm going to choose 1 and 2. So to eliminate x, I'm going to take two lots of equation 1, 2x plus 6y minus 2z is 30. And I'm going to use equation 2, 2x plus y plus z is 7. And I can see if I subtract those, I'll eliminate x. So 6y minus y is 5y, minus 2z minus z is minus 3z, and 30 minus 7 is 23. I'm going to call that equation 4. I'll come back to that in a moment. I'm also now going to eliminate the x from a different pair of equations. Again, you can pick whichever ones you want. I could pick 1 and 3. I can pick 2 and 3. Doesn't really matter. I'm just going to go for 2 and 3. So I'm going to go equation 2 is 2x plus y plus z is 7. I'm going to go 2 times equation 3 is 2x minus 2y minus 4z is 0. And again, if I subtract those, I see that I can eliminate the x's. Y minus minus 2y is 3y. Z minus minus 4z is plus 5z. And 7 minus 0 is 7. Call that equation 5. So what I've got now, I've reduced that system to two equations in two unknowns. So I can now set about solving these. So let's go. I need to make either the y's or the z's match. So let's make the y's match. I'm going to take 3 lots of equation 5, which is going to be 15y minus 9z is 69. And then I'm going to take 5 lots of equation 5. 5 lots of 5 gives me 15y plus 25z is equal to 5 7's 35. Again, I can see if I subtract these, I'm going to eliminate the y. So I've got here minus 9 minus 25 is minus 34z. 69 minus 35 is 34. That tells me that z is minus 1. Okay, so I've got one of the variables sorted out. As soon as z is minus 1, I can come back up to either of these equations. So I can say now equation 4 tells me that 5y is going to be 23 plus 3z. So y turns out to be 4. And as soon as I've got that, I can go back to any of the original equations at the start. Let's go. Equation 1 is going to tell me that x is equal to 15 plus z minus 3y. I use any of these. That will eventually tell me that x is equal to 2. So what I've found here is that these three planes have a unique solution. There's only one solution. They intersect at the point, and I've also found, of course, the coordinate of that point, which is 2, 4, minus 1. So I found out by doing that systematic investigation the geometric relationship between these planes. Of course, in this system here, you may well find shortcuts. You may well have spotted it was probably easier for me to eliminate x's from equation 1 and 3 rather than 2 and 3 here. You might have found it easy to eliminate the z's in a different question. So keep your eyes open for little shortcuts in that systematic elimination of variables in the middle, and interpret your answer appropriately at the end.